So that brings me to the next point and the last of this block, but maybe also an exciting one. The portal walkthrough and also the everything you can do in terms of the visualization. And I'm very glad to welcome Nikolas Ott. He is the main developer of the mapping and visualization part, and will give us a short introduction on the technical part, and then I will take over and guide you through, let's say, the mapping application. Perfect, thanks.
Hey, thanks for the introduction. Yeah, also one aspect of the project was to develop some, like a set of tools for the exploration and visualization of the global heat flow database. And like the goal was to allow users with a very low threshold to explore the data already within the browser. So you do not have to import it in your GIS. You can just go into the browser, have a look at the database, get a feeling on how the data is distributed around the globe, check out the values and so on. Therefore, we implemented a client-side web application. That means the application runs on the user devices. Therefore, we used a bunch of libraries. They are listed up in this small screen over there. Like the app is developed mainly in Vue.js, which is a JavaScript framework, front-end framework. Within there, we use Pinia for the internal state management, like dealing with the data, manipulating data, putting the logic within the application. Then for the mapping itself, we use MapLibre that brings like the power to visualize the data around the globe, like with this mapping views. For the interactive elements like buttons, accordions, and so on, we use Bootstrap. And for the interactive graphs and charts, we use Plotly. Now, just a short explanation what is going on when you as a user call the domain. Like, don't worry, you do not have to follow those steps. It will be done in the background for you. So as a user, you request the server, let's say. The server sends you back like the application as a JavaScript, HTML and CSS file. And then all the stuff is done on your local machine, like the rendering, the calculation, and so on. The application itself fetches the global heat flow database as a CSV file from an online repository, converts it into GeoJSON, and then it can be used as input for MapLibre. So you can see it on the screen. And then it's up to you to start the exploration. And I will hand over to Sven to guide you through the portal. Thanks.
Yeah, thanks. Yeah, the nice thing, if you are a project PI, you can do the cool stuff yourself, right? Okay, so welcome with this part. What can you do with the mapping app? And this is probably what most people are just seeing online. Of course, with the mapping application we have built, and which was beautifully explained in the technical backgrounds, you have all these standard navigations you know from these usual systems. You can switch between these global and the map views. Having your own Google Earth experience here, if you would like to say. And obviously you have these kind of customization information points, so you can click on each of these points that you get the first information about what data point you actually have at the point you are. This will be a bit extended, so we will interlink this also with the respective literature and so on. Besides the controls, there are obviously a number of settings you could use. So the usual base maps you can use and you are used to use. You can customize your views as you want in terms of all the colors and sizes, which helps to design the things you like to have it or it is suitable for. Data-driven coloring with all the different metadata, and now you will quickly see why metadata and additional information are really supportive and informative. You can use different types of metadata and drive your colors according to that, including then also the quality schemes and so on. And we have already implemented some layer over functions. So here some gridding of the 2024 global heat flow release. And we will extend this functionality in future as well. So the next is to extend these kind of data lists, for example, crustal data, further geophysical data set that you can enhance, let's say, the type of analysis you would like to do depending on what you're interested in. This also belongs to filter the data. The more metadata you have, the better you can customize the data set you are interested in and let it show here on the screen. So there are variable attribute filters that could be the heat flow value, it could be the depth in which it is measured, it could be the environment in which it was derived. So all kind of these customizations, and you can add it. Yeah? So edit multiple filters with custom data ranges is here an essential landmark you can use, and you can somehow combine it the way you need it. Because either you're doing geodynamic research, climate research, biological research, your demands of information are different, and this is what we're paying attribute to. Of course, you also can add then these kind of manual selections because you already know specific regions you are interested in, and you can store these kind of selections for the next step, which will then be going to the statistics. Anyway, next would be, of course, that we extend these downloads. Until now, you can download this as GeoJSON file, but in future, there will be further formats you're more used to. And these kind of selection you can then take over into the statistics. So that is the third option you see at the bottom line here. Use any kind of parameter or any kind of selected parameters from the database to make your own individual statistics. You can do this for the entire database or for the selection you have made. So there are some possibilities to explore these kind of data online live and download in future also the selection of data you want to have directly on your desktop. The next thing will be also that we generate PDF reports of the selection of data and the statistics we have done. The more intriguing and cool things are to work with these data online and to use it as a kind of education tool. And so what we can do is, or what you can do as user, print 1D geotherms. So you can do temperature depth profiles anywhere you are. Let's say somehow you can add the different numbers of layers here. You can modify the heat production or thermal conductivity, the thickness of the layers and the numbers. So you can work on a crustal scale, you can work on a very shallow scale. You can use this as somehow to show students how things are working and at different spots. At the moment, that are generic values. But in future, we want also to add structural data from crustal models, ECM1, for example, or land surface temperature data that are globally available that you can automatically pick or it can automatically pick the local conditions at the specific spot you are interested in. So global surface temperature data from MODIS, we will also think about to add global thermal parameter models, which could be developed in future and give you already parameter sets that are attributed to the crustal phases you are dealing with in this specific area. On top, also in future, we will include things like in situ correction methods that we are a bit closer to reality of these kind of geotherms. But anyway, 1D is cool, 2D is maybe even cooler. So do some 2D profiles. For that, you can just select a transect wherever you are and you are interested in, and can calculate or let's say display the values along these kind of transect or cross-section if you want so. You define for this purpose an orthogonal distance, so a kind of buffer from the transect to include the data along this line. And you can customize the data buffer. So you get along the segment length and your data here displayed as heat flow data on the y-axis. You also see the distance of the data points along this at the specific points. And here, the uncertainties, for example, are also plotted. And we want to extend this, right? We want to extend this tool, adding topography, bathymetry, for example, along the segment line, also adding the quality indicators we have into the segment line. So pushing all these kind of two tools that you get more information that is already stored in the database and available for further use. Beside heat flow depth calculations or these heat flow cross sections, we also think about to add some real 2D cross sections based on the global crustal models we have seen and the parameter sets. And this then will be also available as a report, either as a data export, download options, or as a PDF report, right? So you see 1D, 2D, that are some exploration tools on which you can use and where students also can work with to get a better understanding. And the education part in future is really a crucial thing to us. I think this could be one of the big strengths of this portal, that we have the most recent data available and everyone already can go for it and play a bit around. So this is the same we think about the community. So imaging and showing and broadcasting the people behind the data. So the researcher also on this map, so visualize the community. So where are the researcher? Where are the institute? Where are the tools and labs available? All these kind of stuff you find in the projects and the data portal. We would like also to visualize in this map. So to make it more interactive and more informative for all of us. Despite of that, you have always a chance to download the latest release and do whatever you want on your own private machine, right? Yes, that's what you can do. And there's probably even more to come. And right now we have a couple of minutes left, so I would like to ask all the presenters to come to stage, and you have some time for questions before we can go into a break and having some coffee and something to eat and whatever you wish. So please, Sama, Kirsten, Nikolas, Sam, Florian, Elif, and Alexei, please come on stage. And if you have questions, we have good 10 minutes, 5 to 10 minutes to give you answers on this point. Yeah. You also can clap for 7 minutes. That would be fine as one of us. Yes.
Yeah, Sven and the team, I'm very impressed. I'm somebody who has provided data to the World Heat Flow database 40 years ago, and therefore I'm impressed with where the data comes in. One idea, it's perhaps something for the future. We have learned a lot about thermal parameters, thermal conductivity, and you mentioned it in a kind of disclaimer that the transient properties may have influenced the data. Is there an idea to extend this database to transient data, such like thermal diffusivity or other parameters?
Yes, thanks, Ernst, for this question. There are two elements in it. First of all, and I will show it later in another presentation as well, what we have at the moment is we, for the first time, see what we actually have. So we have a very colorful combination of data, which has been all measured under different circumstances. So the base we have laid here yields the possibility that for the first time we can correct all these effects, all these conditions to a, let's say, unique level and a fixed level of quality. So, for example, we could correct it for the first time for terrestrial heat flow, which is one major idea. This would be sensu stricto, the heat flow at the surface, which is not perturbed by any effects to the shallow or the climate and so on. This wasn't possible. So in the past 80 years, we had really an undetermined combination of data in a database where you never knew whether this is really a terrestrial heat flow, this is climatically perturbed, this is perturbed by flow or any other effects. This is the one thing. The second one, and this directly asks or answers more the question, we have done the standardization for heat flow. We think to extend the database in future also for further parameters like thermal properties implemented, but also temperature and other things, but we will introduce it a bit later.
I will use the microphone because I'm nearby.
Okay, so thanks for this impressive presentation. I was a witness of that Montreal meeting, and I would like to congratulate this team for this enormous effort. It was at that meeting when I gave up after 2.5 hours, but Andrea, Förster, and Sven, they stayed. They stayed with this group of people on the photo for 4 hours to break the ice of decades of, oh, we should, but it's so difficult to assess the quality, and they started the process, and that's really a major achievement. So thanks for that. And my future directed question goes also a bit similar to Ernst. How are you planning to include like this crustal Litho 1 model of Gabi-Lasquer or other tomography data, for example, or the property database? Are you planning to link up with these other existing databases and proceed in this direction?
Yeah, the nice thing with a fair database is that interoperability is part of it. So yes, we think about, obviously, about linking to these required databases. And we do not think about to store everything ourselves, but to make this interoperable with the data sets.
Hello. Yeah, congratulations once again. Quick technical question. So this relational database, is it in SQL format? So can I interact with it via the SQL queries, so to say?
No, no. So I don't think there's any plans to release it in SQL format. But obviously we can talk about that. I mean, it's all, you know, it's open. But the problem is that we've got a user authentication system built in there as well. So we've got private data. So I don't know how we would extract that out and then just publish an SQL database. So we will encourage people to probably try and access data. If you want to do it programmatically through an API, we're making efforts to include an API in this. It's not perfect yet, but we're going to work on it. And so that'll be the main way to do that and access the database, I guess, in that way. Yeah.
Thank you. And the second short one, is it possible to make a world heat flow map? Is it using this many data points? Because obviously some of them were published and many people who are maybe not scientists, but kind of nearby from the industry would benefit more, not from a huge cloud of data points, but a simple map. So whose job is that? Yours or some other users, so to say?
It's ours, of course. That's the cherry on the top, right? So this is what everyone wants to have, nice catchy maps. The problem is if you're working through the data and doing the assessment, you start to realize how difficult it is to create this map knowing what's inside the data. And this is why in the second part we will talk a bit about data products, because really coming to a fully corrected setup of data, which is on the same level of information, so purely terrestrial heat flow, then it actually would allow to make a map that is representative. And this is what we, I think, talk about in the second part as well. Maybe last question to Sasha, and I ask all other, and then Tilman Spohn, And then we go into the break, and we have a lot of room for more questions and answering there. So Sasha, please.
Thanks. I'll try to make it short. So first of all, thanks for this nice introduction, and I particularly like this educational aspect of the portal. I already earmarked it for using it in my heat flow lecture in coming fall. These 1D profiles are really great. I have a question on the perturbation part. So 20 years ago, it was easy. You got one heat flow value. You didn't know how good it was, but you had one value. Now with these perturbations, you get, for every effect that you include, you get another value. And then you have to understand what the effect is and how you actually get rid of it. So how do you deal with these different ways of correct for something? And sometimes the signal is actually what you correct away. So that maybe something that you want to get out of the database. So you get a new depth in this one heat flow value according to the perturbations. And I'm wondering how that will be reflected.
Yes. You know, for the first time at all, we have the chance that a new heat flow determination at a location is not just erasing and replacing the old one, because this is what happened in the past. You will hardly find a location where you have two heat flow values in the past compilations. They solved it by there's a corrected and an uncorrected value. But this is a problem. Obviously, if more people and more corrections are done, you have seen we have locations up to 20, 30, 40 child elements. This is a kind of challenge, obviously, because there's a multitude of information, right? We solve this in a way that obviously there is a custodian job to decide which is the best value for the location. This is somehow a semi-transparent process, but when we're talking about data products, so correcting or creating a copy of the database, but where everything is, let's say, corrected to really address value, then we make this transparent. It will be also that there's a full database dump where all the child elements are included, and then you will receive a product where you just get the location value, the best location value, corrected for a specific state. So you can deal with different type of data sets according to your needs. If you are hardcore, want to go really into the details, you can have this full data set, or you work with subsets where you just have, let's say, it grained down to the essential information you need for your specific need.
Thanks.
Tim Manchbohm, the last one.
Congratulations from my side too. This is very impressive.
Probably.
Hello? Congratulations from my side too. This is very impressive. But when I look at the world heat flow data map, you cannot. You have to notice that there are big gaps, in especially on continents. Africa, for instance, something that is immediately apparent. Is there hope from the heat flow community to fill these gaps? Or would you just say, well, we know enough about continental heat flow such that we don't need to go to the Congo and measure there?
Yeah, this is a fair question. You see, this is a young team. They all have some years ahead, and something to do is remained, of course. I mean, if you draw a circle 50 kilometers around each of these data points, and you sum this up from the area point of view, we know from less of 7% of the Earth the heat flow value. This is not much, right? And if you're doing these kind of big maps, then you need to imagine the circle size usually is that big that it, let's say, results in the impression that we know a lot, but in fact, we do not know a lot. Yes, we have done the groundwork to assessing all the history of heat flow data. We have brought this on a level that you can really start to work and understand what's inside, or better understanding what's inside. And it's also the baseline to let's say come up with a map to show, by the way, that are the crucial points where we need to generate data. And usually that will be also connected to geological, geodynamic features. That we, let's say, know, okay, this is really a weakness point and we need to go there because if we solve this part, then we have an overall better representation. Yeah, it's needed, but this needs to be a global community effort. I mean, we are 8 people here. It's not a lot if you see that we are talking about 92% of the Earth's coverage, right?